underway. So this lesson is on, it's on something called point slope form. We did not learn this last year. We'll actually learn it before the next lesson is actually on slope intercept, which we did do last year. This is a little more of a higher level thinking form of a linear equation, but it'll actually make slope intercept make even more sense. So I think this will actually be very helpful to you. Now let's make sure we understand when we're talking about a linear equation, and specifically I'm talking about a linear equation in two variables, all right? So we need two variables for it to be a linear equation. What would you notice about this? Like, for example, are there any exponents anywhere? No, right? So there actually are, but they're all one, right? So that's one characteristic of a linear equation. You have two variables, and the highest power of the variables is 1. That would be one characteristic. Notice on the other side, I have the first equation I have there has an x squared, and that makes that not a linear. That's actually what we call a quadratic equation, all right? The next equation, what do you notice about this equation right here? It's got a cube there, so that makes that one. What do you notice about this equation right here? The exponent is a variable. It's actually the x. The x is the exponent. So that's an exponential equation. Now this one has all the powers of the variable. See this one right here? This one has all the powers of the variable 1, but what's different about this one is the x is in the denominator, and this is actually what we call a rational equation. So, but these are all linear equations. They're actually in what we call a specific form. We call this one standard form. This one is slope-intercept form, and this is what we call point-slope form. Let me pause this a second. I think on my next slide I have that. So I'll specifically identify those on the next page, but these are all actually in what we call a certain type of form. So you'll see this will make sense to you in just a second. All right, so we're going to go. So when I say form of a linear equation, I want you to think of this as giving an equation a uniform like a sports team. It's basically saying have the equation structured or look like other equations that we would consider to be in that form. So when you see an equation, so you see the first one there, standard form, an example of that would be if I had an equation like 4x plus 5y equals 20. That would be a linear equation in standard form. That a and b and c, those are going to have those are variables that stand for constants in real equations. There would be numbers there. The m in slope-intercept, that's the next one. We would have a number before that x, right? That's the slope, and the b is actually your y-intercept. We'll again refresh your recall of that when we get there tomorrow, or the next, not tomorrow, but next week. So an example of an equation in slope-intercept would be like y equals 2/3 x. We could have a subtraction, certainly. It could be positive or negative, -7. That would be an example of an equation. If it's structured like that, where you have the y on one side, and then a number before the x, and then an addition or subtraction of another number, that's slope-intercept. Now, point slope is the one we're learning today. That's one you haven't seen before. And that's going to look like this. So you might have an equation like y minus 5 equals, I'll make a slope of like -3/4 this time. I have an x, and I can have addition or subtraction, plus 2. That would be an equation in what we call point slope form. All right? So you would never have numbers for the x and the y. You can have them for the x sub 1, the y sub 1, but you don't have it because if you just have all numbers, you don't have a linear equation. So you have to have an x and a y to the first power for it to be a linear equation. And you can have equations that are in none of these forms, right? Can anybody, for example, name an equation that would be a linear equation but would not be in any of these forms? Could anybody tell me that would be not in one of these forms, but it's a linear equation?
Corey, what do you think?
I think that just like a basic one, like
A equals 8.
Well, here's what I'm saying. Like if I had it like, let's say, negative 7x equals 3 y plus 4. That's a linear equation. Listen, please. Listen, please. That's a linear equation that's not in any of those forms. Can everybody see that? Why is it not? Now, we could very easily get this one into standard form by doing what? Look at the equation I have in standard form.
You move the x to the other side.
Or move the y term to the other side, right?
Oh, yeah.
Okay? But it's not in slope intercept, not in slope intercept form.
Is it because there's two different variables?
No, there's two different variables in this one over here, right?
Is it or the same?
It's not. The y is not alone by itself. The x term's not sitting there in front of the constant term, right? And it's not in this form. It looks very different from this, right? All right.
So how would you get the y on itself?
I would subtract the 4 and then divide everything by 3. Okay, that would be the way I'd do that. Okay, we'll have plenty of chance to practice that. Yes, Drake.
Why is it so?
Oh yeah, well that's what we're going to talk about now because you haven't ever seen this before. So let's talk about that now and why it is. Now, first of all, just by its name, that's really instructive as to what it's all about. Like remember when we talked about slope intercept, remember the m is the slope and the b is the y-intercept. So when you have an equation in point slope form, that means one of the points is very readily apparent and the slope is readily apparent. If that's the case, you can graph it really easily because you can pick that point and pick the slope to get another point. So here's our first example of point slope. Now let me write the form down. Y minus y sub 1 equals m times x, the quantity x minus x sub 1. All right, yeah, I'll tell you what that means. The x sub 1, y sub 1, all right. So x sub 1, y sub 1. That's a comma, by the way, right here. I'll rewrite that so it's not. All right, I need you to be quiet, Grant. I really do. Okay, so that's x sub 1, y. So that means that what that's going to mean is a given point on the line. On the line that the equation represents. When I say on the line, that's what I mean. The m is what it is always, or what it is in slope intercept, is the slope, right? And the x and the y without the sub 1 are all the possible points on the line. They're the x and y combinations that will make the equation true. They are all the points on the line. Okay, so I'm not even going to write that down.
Do we know how to set it up with the x sub 1?
Well, I know, I haven't even taught you this. I'm just giving you some background right now.
Will you explain to me what's going on here?
I know. Well, you've never seen this before, so I got to let it play out a little bit. So all I've done is what I've done so far here, Max, is this right here is what we call, that's the generic form. Remember, like for example, the Pythagorean theorem is a squared plus b squared equals c squared. This is the generic form of a linear equation in what we call point slope form. So if it's structured like this, that's considered to be in point slope form. Now we're going to actually do our first equation in point slope form. And when you're given a point on the line and the slope, the good thing about this form is you can immediately plug it into this, and right off the bat, you have an equation in what's considered to be point slope form, and that's very helpful. So I'm looking to come up with a linear equation in point slope form that has this point and has this slope. So all I have to do, and by the way, this negative 3 is my x sub 1, this 5 is my y sub 1, and my slope is 2, right? So I'm going to take what's my y value? 5. I say y minus 5 equals, my slope is 2, and then I say x minus negative 3. Now we'll take one more step and simplify that. So this equation, this is your first linear equation that you've done in point slope form, is y minus 5 equals the quantity, or 2 times the quantity, x plus 3. All right? Now, how do we know that that's met? So that's the answer, okay? But how do I know I've succeeded? What does it mean if a point is on the line and I substituted in what should happen? If I plugged in the 3 for the x, I'm sorry, the negative 3 for the x and the y and the 5 for the y, what should happen?
They should have the same answer.
I should have the same thing on both sides, that's right, okay? So what I'm doing now is just like an equation check, essentially, right? I'm going to just show you that, this equation does actually, that negative 3, 5 is actually on the line, all right?
It's like 2x plus 1 equals y.
Can't you solve it for the y equals mx?
You can, yes, you can, and what that would do, and we're going to do that, that would convert it to slope-intercept, okay? And that's valuable, but if you, the great thing about this is it instantaneously gives you an equation, a linear equation, that everybody accepts, right?
What is the point of this method?
The point of this method is that if, like, for example, if I give you a point that's not the y-intercept, and I give you the slope, you'd have to go through multiple steps to get that into slope-intercept form.
Okay.
Whereas this, you have the equation immediately.
Okay, so I haven't, so it's.
This is an accepted, that looks like very unsimplified, doesn't it?
Yeah.
But it's, what I'm telling you is, that's very much accepted as a way to express a linear equation. It's called point slope. And it's a very good question what Max is asking. He's like, what's the point of this, right? Well, if I said, like last year, I would have given you a problem like this, you would have to actually do several steps to get the equation into slope-intercept form. Here, you can do it immediately.
So this
Okay.
is just like helping us.
It's a convenience.
It's like a step in the process to finding the answer.
Are these
It's,
three-
the thing is, there's no steps really, except the only thing I had to do there, Max, was change that subtracting a negative to a addition. So there was one step.
Oh, okay, well, what is, well, I'm saying,
Well-
I guess what I'm asking is like on a test, what would I be doing?
Okay,
Would I be
right,
finding a
right,
point?
yeah,
Would I
you're
be
gonna have to
finding-
let it play out a little bit here. This is just the beginning of the talk, okay? So let me tell you where this all goes. Now, what would be helpful for me to do right now is to graph this for you and show you why it works, okay?
Okay, Mr. Andrews?
Yes,
In y equals mx plus b, b is the y-intercept, right?
that's right, okay? Now, so, I think what I want to do now is just quickly graph this. So remember what this line said. So everybody sketch a graph real quick. So we'll sketch a graph of this really quickly. Quiet, please. Now, the point on the line, remember, is the point negative 3, 5, right? So remember, that point is right here, right? So that's where the point negative 3, 5 is. Everybody agree?
Yeah.
My slope is 2, so I want to go, to graph this line, I would go up 1, 2, over 1, and that's where I'd make another point, and that's what the line would look like for that equation.
Can't you also start, like, if you were to simplify it, have y equals mx plus b, and then use the b's the y-intercept, so the x is 11?
Yeah, we're going to do that. We're going to do that, but what I'm trying to tell you is you've learned that already. You're very comfortable with that. But if I ever gave you this equation just like this, like what I want you to be able to do eventually is see this equation, and you know right off the bat, like instead of me giving you the information of the problem, if I gave you an equation in this form, you wouldn't even have to do that, Morgan. You could just know, oh, x is negative, one of the points on the line is x is negative 3, y is 5, and the slope is 2, and you graph it right off the bat without having to even convert it to slope-intercept, okay?
Wait, can you go over how to graph it again?
Okay, well, I just graphed it from the given information at the top of the problem, which was, it said this had the line contained the point negative 3, 5, and the slope was equal to 2. And remember, if a slope equals 2, that means 2 over 1. So I graphed this point right here, which was negative 3, 5, and then I went up 2, right 1, and I made another point and graphed it. Okay?
Okay, thank you.
All right, now, let's look at another one. All right, so,
I guess here's a better question. I'm not exactly sure like what I'm learning how to do.
right, okay. So what you're learning how to do is take information about a line, okay? And you're gonna put it in an equation. You're actually doing the reverse of graphing. You're getting information about the line and you're putting it into the equation. So, as opposed to being given the equation like you did 2 nights ago, you were given equations.
So we're making an equation to figure out the slope of a line.
No, last night you did slope, okay? Last night you did slope. The previous night, though, what did you do? You were given linear equations and you graphed, Max, this is a good question. We're finding the equation that represents some information we're given about the line, as opposed to being given the equation and told to graph the line. So you're gonna be given, let me just turn this off for just now. So what are we gonna plug in for the x sub 1 and the y sub 1 here?
Y minus negative 6
Equals
equals 3/5 parentheses x minus 2.
x minus 2. And now we'll just simplify that to y plus 6 equals 3/5 times x minus 2. Now, if you saw, no, you want to leave it just like that. Now, listen to me. If you were given this, what you have here is, let's say I didn't give you all this up here, right? And I said, this is all you saw. Could you come up with a point that's on that line? If this is all that you saw, would you know one of the points on the line? Yes. Well, what would you plug into x to get, so if I plugged in 2 for the x there, what would I get on that side of the equation? If I plugged in,
3/5.
no, it'd be 2 minus 2 or 0, right? So I'd get 0. And if I plugged in negative 6 here, what would I get?
0.
0. So that means that's a solution to the equation. All right? Now, so I would know right off the bat that 2, negative 6 is a point on the line, and then I'd go up 3, right 5, and I'd have another point. I could do that as many times as I want to get another point. Okay? All right.
Wait, 2 negative 6 or negative 2 6?
2, negative 6, because remember, what makes this side of the equation 0 would be 2. What makes this side of the equation 0 would be negative 6. And that would make it true. Now, can anybody think of what would be another point on this line? What's the slope? So if the point 2, negative 6 is on the line, if I went up 3 on my y, what would I have? From negative 6. And if I went up 5 on my x, 7. Now let's plug that in real quick and see what happens. If I plugged a 7 here and a negative 3 here, what would I get? That side would be 5, 3/5 of 5, which is 3, and this side over here would be also 3, right? Negative 3 plus 6. So that means it's... Well, what I'm saying is, remember, the thing you got to remember is that points on a line are solutions to that line. I should be able to plug them into the equation and make them true. So what I was just showing you, I just found another point using the slope, and it made the equation true. What would be another point on the line?
Negative 5, negative 9.
12.
That's right. So if I plug 12 in for x, what do I get? I get 12 minus 2, which is 10. 3/5 of 10 is 6. And on the other side, I get 12, let's see. I'm sorry, I go 12 minus 2 is 10, and I plug 0 there. I get 6 equals 6, right? Okay? So, let's keep going. I think the more it'll come clear. Now let's go the opposite. Here's a line, okay?
This is a really complicated way to find
Yeah, but it's going to really help you understand the bigger picture when you gotta let it kind of, sink in a little bit in this talk, and then do the homework, and then I think when you come back to class next week, it'll really make sense to you. All right, now listen. So here's an equation. What point did I identify in red there? What point is that? Be careful and count it correctly. Well, here's the origin, right? So So what point is that?
Negative something.
Well, it's there, so it's negative 1, 2, 3, 4, 5. So negative 5, 3, okay? So that's a point on the line. Now, what is the slope? I tried to make it pretty, nice and straight here, so it's got that, it's got that, it's got that. So to me, it's a down 2, a down 1, right 2.
Yeah, I hear that.
So the slope is negative 1 over 2. Can we put this in point slope form?
Yes,
Yes.
y minus 3 equals, negative 1/2, parentheses x
plus
minus,
five.
yes, under, or you have to put.
You're right, x plus 5. Now, Morgan has been clamoring for us to now convert it into slope-intercept form. So, clamoring just means she's been very enthusiastic to want us to do this. So now, and some of the homework problems do ask you to do this, now let's convert it, let's solve for y. So I need to distribute the negative 1/2 first. Sorry, don't do that. So I'm going to leave the y minus 3 alone for a second. I'm going to distribute the 1/2, okay? So that's negative 1/2 x. That'll be minus 5/2, okay? Now, realize that since I got to add 3 to both sides and I got to add it to negative 5/2, let's use a denominator of 2. So I'm going to add 6/2. Is that all right?
Yeah.
Why are we adding 6 halves?
Because I just wanted, since I need to combine this over here, Grant,
Making a slope intercept.
with this, I need to add 3 to both sides, right?
Oh,
So I just did that in a fraction form. So in solving for y, this equation equals negative 1/2 x plus 1/2. Now those of you that remember slope-intercept form, this is your y-intercept, and notice right here at negative 1/2 is where that shows up, right? And my slope, as we found before, is negative 1/2. So see how those two forms,
So y,
What does
See how those two
Y stand
forms-
for?
the y stands for all the possible y's of the points on the line, all right? The x stands
Like
for,
y equals, that way that stands for all.
well, in every form of the linear equation, the y stands for the y values for every point on the line. The x stands for the x values for every point on the line, all right?
Wait, so the y
Wait,
equals mx plus
Mr. Andrews,
b is the y-intercept, but y is all y
b
values.
is.
It's all y values on the line. So for example, here's our equation in slope-intercept form. What is a point on the line? Negative 5, 3. Well, let's use something else since that's one of our points. How about if we use negative 3, 2? So what that means, Emma, is that I should be able to pick any point, plug the y in for the y, and plug the x in for the x, and it'll make it true. So if I plug negative 3 in for x, I get positive 3/2 plus 1/2 is 4. I'm sorry, I get positive 3/2 plus 1/2 is 4/2 or 2. And on the other side, y equals 2. So I get 2 equals 2 when I do that. And so it should always make it true.
Mr. Andrews?
Yes.
Wouldn't it be plus 5 over 2 instead of plus 6 over 2?
No, because I'm adding 3/2. I want to get rid of that negative 3 over there. So I'm adding positive 3. Okay, I'm not trying to get the negative 5/2 the other side. I'm trying to get the
Oh, you
negative
just
3.
put it in fraction form.
Yes. What's that? Scissors, up there somewhere. All right. Let me see if I have another problem on this page. All right. Okay. All right. Okay, here we go. So another one of these. So, write the equation for the line in point slope form, then solve for y. So what's the given point I have this time?
4, -1.
4,
Can't see.
-1.
Yeah, it is hard.
Okay? 4, -1. So what's my equation in point slope form?
Y plus 1
That's
Yeah,
right.
Y plus 1 equals,
Now what's my slope?
1.
It's not 1. Oh, actually,
Yeah.
yeah. I'll buy that.
1,
Yeah, it's 1. So I'm not, so I can put a 1 in there or just put nothing,
yeah.
all right? X minus 4.
So that means that y equals x minus 3.
Okay, so if I convert it, yes, that's right, that'd be minus 5.
Mr. Andrew, your points are for negative one, right?
Right, so that's why I plugged, remember the point slope form, it's y minus y sub 1. So it goes to a plus. Now that's good to ask that. I'm sorry, that should be a 1 there, guys. I don't know why I put a 5, because that's the outcome.
Why is it y plus?
The slope is 1 on that one.
Shouldn't it be y minus one?
Yes, yes. So it's y equals x minus 5. Notice that there's my y-intercept like it should be at negative 5, right? You see that?
Yeah.
Starting to come together?
And then the slope is 1, so we don't represent it because it's just already, it's in X.
Yeah, well, it's there, and anytime you don't write it, it just means 1 over 1.
No, but originally, shouldn't it be y minus one? 'Cause
No, actually, Grant, it should be plus, because remember, the point slope form is y minus y sub 1, and if the y is negative, that's going to mean a plus, right? Now, so here are the two tasks were to find the equation in point slope form, and then solve for y. So those are my 2 outcomes. So, it says, all right, this one says, write the equation. Now, what happens if I give you 2 points and not the slope?
You find the slope.
Right, find the slope. So, negative 3 minus negative 1 over 7 minus 4. So I got to find my slope first, and then I can pick either point and put it in point slope form. Not both, though. So negative 3 plus 1 is negative 2 over 3. So that's my slope. Now, I pick either one of these points to put it in point slope, not both. So I'm going to use the first one. So if I use the first one, it would be what? Y
Plus 1.
plus 1 equals negative 2/3
Open parentheses X. Plus, minus 4.
minus 4. Now, by the way, when I convert this to y equals form, it would come out the same whether I use 7 and negative 3 or 4 and negative 1. You just have to trust me on that. I don't want to take the time to do that, but test it out yourself if you don't believe me. So negative 2/3 x, and then, so this will be negative or positive 8/3, right? So since I have a denominator there of 3, I'm going to subtract 3/3. So my equation in y equals form will be, and we'll know that tomorrow again to be slope-intercept form, y equals negative 2/3 x minus, or I'm sorry, plus 5/3. All right? And then this was our other task to get it in.
So 5 over 3 is the y-intercept?
Exactly. Now remember, both of these equations, it would be like if, if Josh Hamilton was wearing, he played for 2 different teams this year. If he was wearing his Angels uniform or he was wearing his Texas Rangers uniform, he's still Josh Hamilton. All right. So these 2 equations represent the same line. Okay. All right. Almost there. Okay. Now let's go the opposite way. All right, friends. Let's go the opposite way now. Now I'm going to give you an equation in point slope form, and you're going to tell me, you're going to graph the line for me. So what's the slope in this equation?
Negative 2/3.
So I'll put the negative in the numerator, doesn't matter. What is the point? Negative 7, positive 5.
No, it's
Remember, how would we have gotten a plus 7? How would we have gotten a plus 7? Yeah, so it's negative 7, 5. So I'm going to go negative 7, 5.
Wait, isn't it 7 negative 5?
Nope. Remember, what would have gotten me a negative 7 there? If I plugged it in, the point into point slope form.
Negative 7 plus 7 is 0.
Right? And then that's the other thing, it'll make the equation equal 0. And then I go down 2, right 3 as many times as I want, right?
Ta-da.
And there's my line. all right? Now, I see some of you just staring at your page. I don't see you. So one word problem, this is the last problem in the notes. An antique clock is expected to be worth $350 after 2 years and $530 after 5 years. What will the clock be worth after 7 years? This is a classic problem where we're going to think of this in terms of, as time goes on, the value of the clock is going up. So we can think of, so in this problem, we're going to say let x equal the number of years, right? We're going to let y, anybody know what I'm going to let y equal?
Time. Value, right?
Value of the clock, right? So they're indirectly giving you 2 points here, aren't they?
Yeah.
What is one of the points in this problem?
250.
350, very good.
This isn't a homework lesson.
Okay,
Not
but
the
it's,
exact
but
same
it's,
question.
yeah, but it's gonna be in, we're gonna put it in point slope form here. So last night it might have said just find the slope, now we're gonna put it in point slope form. So, the other,
It's 5:30.
okay,
Good job, George.
now, what I'm gonna ask you to do is I'm gonna ask you to find the slope first. So that's 530 minus 350, right? And 5 minus 2. So 530 minus 350 is 180, right?
Yeah.
180 over 3,
Slope is 60.
so equals 60, and that means $60 per 1 year. All right, so that's your slope. So in point slope form,
You get 5,530.
no, I didn't get,
5,
okay. Now what's this equation in point slope form? Pick either form, pick either point.
Y minus.
Y minus 350 equals 60 times x minus 2. Now, if I want to find out what that clock is worth after 7 years, I'm just going to say x equals 7, put it in there, and solve this equation for y. So y minus 350 equals 60 times 7, the quantity 7 minus 2. So that means what? That means y minus 350
Y equals 60.
equals 60 times 5. So y minus 350 equals 300. I add 350, and after 7 years, the clock is worth $650, right?
Wait, why did you multiply by 5?
Why did I multiply by 5? Because that's what 7 minus 2 was. Okay? All right. We